Hello. Today I thought of discussing quite a problem actually everyone is facing when solving physics questions. This actually came into my mind actually when I was teaching to grade 12 students. Uh, at the beginning of fundamental of physics lessons actually we study vectors and equilibrium of forces. Sometimes we may not give that much of attention to it. We move into the next lessons. But actually, right, when you are moving into deeper into physics lessons, actually the equilibrium of forces will come in handy quite a lot. It's available everywhere. Say now, when you are doing field, electric field, magnetic field, and gravitational field as well, and of course simple harmonic motion and all the mechanics questions, we have to get questions, we have to allocate the forces, and we have to consider an equilibrium, right, for a certain object or something like that. Then only we need to apply physics equations and we do the question. So what I'm suggesting you guys is that we need to practice quite a lot of these equilibrium of forces questions at the beginning of fundamental of physics lessons. Like earlier, we need to practice quite a lot with vectors, how to get the components of vectors, and how to get the equilibrium, how to balance vertical forces, horizontal forces, and the torque as well. The torque has to be zero for the equilibrium. So things like that, these type of questions you need to practice again and again. You have to repeat these questions, because when you practice these questions you will be really good with it. It's a skill, right? So once you practice, once you have this skill, right, you have the ability to do the other questions as well, other force type questions, electric field, magnetic field, gravitational field, uh, others as well. So I'm suggesting you guys keep practicing these type of questions every week, right? So I'll give you a couple of questions, couple of examples, so you'll understand what I'm talking about. Then practice these type of questions every week, so you will be a master with physics questions, because this might be the reason that you feel physics questions are not easy. Then it comes to force type of questions, force or allocating a force, considering equilibrium of things like that. Right, let's get into the question, and I'll discuss a little bit further in the questions as well. Right, now we are doing the very first question. This is the question now we have. See, it's a very easy question, so I'm starting with a very easy question. So in this type of questions, actually what we have to do is to find the value of the tension. What you should do is you have to get the components of the forces. So you have to take it for the vertical direction, vertical forces, vertical equilibrium, upward forces must be equal to downward forces. And at the same time, you should equal the horizontal forces. The tension goes in this direction and the other tension goes this direction, both are equal, it cancel off. So this method to allocating the tensions or the forces in vertical plane and horizontal plane is a must. That ability you should have. Right, let's do this question now. Let's start with the question. This question now, here as I mentioned earlier, vertical forces and horizontal forces. So let's take the component. Now the angle is easy, this 60 and this 60, these two angles are equal, so that means the tension we can assume it's same because it's the same bar as well. So T here, so let's take the components to this side. So it's T cos theta plus T cos theta. That should be equal to the value of mg. At the same time, we can take T sin theta, this direction should be equal to this direction. It's in equilibrium. T sin theta. Actually here we do not need this thing, only from this we can solve the question actually. So T is same, it's 2T cos theta, you can see that, 2 into T cos 60. I hope you know the value of cos 60. That equals mg, that is 20 Newton. Right, let's solve the question now. 2T cos 60, that is half, equals 20. That's a very easy question. T equals 20 Newton. That's an easy question. Into the second question. So this question also not that difficult. Let's do the question. Right, here actually they are asking us to find the tension, the weight here and the tension here as well. So we are doing the very same method. Vertical forces must be equal to the vertical equilibrium. Upward forces is equal to the downward forces, and horizontal forces are equal. Same method. So let's find the tension here first. So let's take the components of this tension. So we take it to the horizontal direction. So it goes in this way, T, and we take this angle. So it's T sine 60, and this direction it's T cos 60. Right, now we have taken the components, result, right? So for the equilibrium, upward forces must be equal to the downward forces. So T sine 60, that should be equal to W. So here of course we don't know tension and we don't know W. So we need to wait for a moment and let's find from the horizontal direction. This direction we have T cos 60. T cos 60, that should be equal to, it's easy, 30 Newton. So cos 60 half, so T half is 30. So that means T equals 60 Newton. We know the value, right? We have found the value, right? Moving into the second part. So they're asking us to find the value of W. So now we know the tension. Let's substitute it here. So it's T sine 60. T sine 60, that is equal to W, right here. So T sine 60 root 3 over 2, that equals W. So T we have found it's 60. So 60 into root 3 over 2, that is T, is W. So it's 30 root 3, that is W. So we have the two answers. Right, students, moving into the third question. Right, this question, I hope if you can do it, just write, okay? Right, let's get into the question. In the very same method, actually, we are trying to solve the question upward forces and downward force method. Right. So let's write the upward forces now. For the equilibrium is of this 1 kilogram object. So downwards we have mg 10 Newton. So what are the upward forces we have? From T, we get here T cos theta. This direction we get, let's say here also 30. So this direction we get T cos 30, and of course this direction T sin 30. So we have taken the components, we have resolved it. And F of course we need to do. So this direction we get, yes, F cos 60, and this direction F sin 60. So we have resolved the force, right? So we have done it. And upward forces must be equal to downward forces for the equilibrium. So for the equilibrium of this object, so I'm writing upward forces T cos 30. T cos 30. That has to be equal. Downwards we have of course mg 10 Newton plus from this F cos 30 it's downwards. So F cos 60. Right. So T cos 30. T cos 30 of course root 3 over 2 plus 10 plus cos F over 2. Right. So in this equation actually you can see we have two unknowns. Two unknowns, two equations. Right. Let's get the other equation of course from the horizontal equilibrium. Right. So here we have T sin 30 and here we have F sin 60. T sin 30, that is half, that should be equal to, on this direction we have F sin 60, that is root 3 over 2. So F into root 3 over 2. So T equals, let's take it over there, F root 3. Right. So what we can do is we can substitute of course T from F root 3. Let's do it here. Right over here. So T cos 30, T cos 30, T this root 3 over through F, right? Cos 30 root 3 over 2 equals 10 plus F over 2, right? So let's take F into one side here, it's 10, right? So then 10 equals root 3 into root 3, that's 3 over 2. So F 3 over 2 minus F over 2. 1.5 minus 0.5 is of course 1. So F equals, we get 10 Newton. Right. So we have the answer for F. If F is 10 Newton, of course we can apply it here. So T equals root 3 into 10. 10 root 3, that is the tension here, right? So these questions actually, I'm saying we need to practice these type of questions. Say in let's say we are moving into electric field or magnetic field, gravitational field, or any sort of other question. Even viscosity, there can be a question like this. So from somehow this F value will be given from other lessons, actually electric field, magnetic force, electric force, or something like that. And then we need to find the tension. So from that lesson we can find F value for sure. But then to solve the question, you need to apply this equilibrium theory knowledge. So if you are really good with, if you have this skill how to take the components and everything, you are good to go with the question. Maybe you can learn really well the theory, but still you cannot apply because of this. So for the students who have time, so you can keep practicing this. If you are really good with arranging the components and taking the equilibrium questions, you are good to go with physics questions.